Hello everyone, and welcome to Introduction to Geographic Information Systems. I'm Dr. Richel Sachenko, and I will be conducting this course. Now, Introduction to Geographic Information Systems is a foundation course, meaning that it's going to provide for you the basic theoretical and technical skills that you would expect from a GIS user. However, though, when it comes to GIS, you could literally get your PhD in Geographic Information Systems. So for those of you who take this course and you're just really amazed by GIS and you like it and you want to go further, trust me, the road is there. There is still plenty of content out there for you to learn. And by the way, this image that you see here, it's a GIS project that one of my students submitted for his final project in a GIS course, where this is Fort Hays State University, and it was rather interesting management GIS in that if you clicked on any of the buildings, you would have gotten the series of floor plans, but also it was designed so that way if students were to say, hey, I need to know where my classroom is, and I have no idea where to go and what directions to go, it would help a student navigate around campus and actually get the information about the location in the building and all sorts of things like that. So it was just a very clever GIS final project. Now, who uses GIS? Maybe the better question to answer is who doesn't use GIS. You're going to find that aside from these major agencies and organizations that are identified here in the slide, there is so much more out there, everyone. I mean, it's just amazing how GIS has permeated our society. And there's a very interesting story behind how this all happened, which we'll cover in the history of GIS. But suffice to say, GIS has made its mark in our society. Now, what can you do with GIS? For the remainder of this presentation, what I'd like to do is share with you some interesting applications of GIS. But please note, though, that these are only going to be a few, and there's only so much time in the day to share information with you. And you could have an entire semester course on just GIS applications. That's how many there are. But let me share a few interesting ones with you now. Now, for starters, GIS has a cartographic aspect to it. And now, thanks to all of our mobile devices, it seems like we've all become super map users. And wow, hasn't that revolutionized the way we do things? Being able to pick up a mobile device and simply say, can you tell me where something is? Well, that is one element of GIS, but well, you might say when it comes to public service, just producing a map on the fly of what it is you want to see in the area that you live, like for instance this example here, grocery stores in Detroit, how beneficial this is to just simply know where things are and have the information shared with you so quickly when you're walking around or on the go. Just think how that how much easier life is because we have that information. But now, aside from knowing where things are in our community, GIS also has a great way of helping us make decisions that benefit our lives. Now, when it comes to ATM machines, for instance, this example here is ATM locations in Singapore. Do you ever wonder how they decide to put an ATM machine on the landscape? Now, of course, the host bank quite often, they have a machine right there. But have you ever seen ATM machines that are just kind of, in different places? There are studies using GIS that are conducted so that they can put a ATM machine in a location where they feel like it's going to be utilized the most. Like for instance, between a community, a regular neighborhood, and say for instance a place where folks are going to work. they do studies where they say, hey, by the way, there's a certain distance that people are going to travel, and this seems like it's between the people who need the money and where they want to spend the money, things like that. So this is just another example of GIS making life, well, a little bit more convenient for all of us. Now, aside from the conveniences GIS provides all of us, there is also the element of meeting the requirements of a necessity. Welcome to San Francisco, California, USA. One of the nicer cities I've had the privilege to visit in this world. Well, San Francisco has actually quite a robust GIS to manage this city. And one of the reasons that San Francisco is such a good GIS user is because, well, number one, everybody, I believe, knows that San Francisco suffers from earthquake hazards. Now, in an earthquake, the last thing you want to encounter is having problems sharing data. By utilizing GIS to pull together information about the city from a variety of locations and management, that I mean, say for instance, the public utilities department, and maybe the fire department, and the police department, and city hall, places that were located in different locations in the city, and they had their own unique data. Can you imagine geographically tying them together so that way more seamlessly decisions can be made? But by the way, aside from the grim thought of a disaster, it just makes the city that much more efficient. It saves money, and services are provided to the public in a more effective way. And the image that you see here is a rendering of San Francisco 3D, and wow, you look at that and you say, just it seems like 3D views like this, these seem to get better and better with time. And by the way, three-dimensional images, they allow us to bring in the human element when it comes to analysis, the seeing that human beings do when it comes to an area to help make decisions. Now, it doesn't have to be only major cities that benefit from using GIS for management purposes. Even at the town level, all throughout the world, there are communities that are utilizing GIS to help make them more efficient, to improve on public safety, and to, well, better share their information, but also have the ability to pull in geographic information system data from other sources that help manage their communities. Now, one of the major ways that GIS is being used in a very effective manner is in public health. Now, this map is showing access to health care and inadequacies. You're going to see that the health industry has been using GIS for quite a while to help both do analysis like this, but also helping manage health resources all across the landscape. Identifying where, say, for instance, if there are, say, a number of people who need, say, a cardiologist within a certain distance, to be able to identify the need and somehow perhaps either provide a cardiologist or at least find some way to connect those people in however they do it. But still, it is a wonderful tool for making sure that medical resources are utilized in the most effective way. Now, a really good example of the use of GIS in healthcare, of all things, is ambulance services. Now, have you ever wondered when they make the call, when to send an ambulance versus, say, a helicopter? Or, when the ambulance is going to respond, do you think that they just simply go the most direct route? Now with GIS and with traffic data that is streamed in live into the systems, You could find out, say, where there are traffic jams, where there is construction, and so you could actually get an estimate how quickly an ambulance can get somewhere. And once you do that calculation, if they say, hey, by the way, we're just not going to get there, say, within, say, 15 minutes, which is essential, or whatever time period, okay, well, maybe then you have to go to plan B, which is a helicopter. And then with a helicopter, the next thing you have to figure out is, okay, so where are we going to land? Because let's face it, accidents, like road accidents, they're impolite events, and they can happen just about anywhere. Well, maybe they can pull up an aerial map that's within your GIS or GIS data and say, by the way, there's this high school parking lot that is nearby, so we could use that for the helicopter, or perhaps some other location that's convenient for landing. Now, when it comes to GIS use in law enforcement, you're going to see that the police are very much on board with GIS. Now, in this slide, you see an example, a cartographic example of a map that's showing crime indexes and showing the number of incidences throughout the United States. And this is useful. This is a cartographic product. However, though, when it comes to law enforcement and GIS analysis, there is an area in and completely of itself. Geographic profilers, for instance, people who are GIS analysts who also are criminologists and are able to take the knowledge base of law enforcement and infuse it into GIS, so that way you can predict, say, for instance, where potential crimes will occur in the future, allocation of resources in a community, so that way the police can be most efficient, and all sorts of things like that. And I was privileged with visiting a crime analyst a couple of years ago, and I was just amazed on how well law enforcement utilizes GIS. Now, here we have the picture of a cute bird. I put this in here because I figured what lecture wouldn't be complete without a picture of a pretty bird. Now, actually, this is now an example of the use of GIS in biology. And biologists have also really tapped into the power of GIS in a variety of ways. Some very good GIS users in the discipline of biology. Now, for instance, this bird right here, the bird gets tagged with a homing beacon or transmitter, excuse me, and away it goes along with, say, a flock of other birds. And of course, the theory is that if you tag an animal, that means that whether it be a flock of or herd of or whatever, the odds are there are others that are moving in the same direction, have the same kind of behavior pattern. Well, let's check out the next map. Now, here in this map, it shows the bird migrations all across the planet of various bird species, and by tagging the animals, we can see what directions they go, but also with GIS, other factors too, like, say, for instance, if the weather patterns were different, if say the landscape was under stress because of drought or something like that, and would that change the direction of the bird's flight path, or where a herd of animals would be found? So there's some very, very interesting studies, and definitely this is a major tool when it comes to trying to protect endangered species throughout the planet. Now, a good example of that is the map that you see here, the critical habitat map of the northwestern portion of the United States. And, well, what makes up a critical habitat? Is it a political boundary? No, not at all. The animals have their environment and their needs, and utilizing GIS, you can bring in the environmental data, the hydrologic data, the biological data, but then you could also bring in the stress factors, say, for instance, communities that are being built in areas where there are endangered species, and do quantitative analysis to determine, what is the stress level on these environments of these endangered species. Now, in order to do these kinds of analysis, GIS has tools like the one you see here called Raster Calculator, which allows you to bring in different kinds of information that's been processed and actually weigh the value that the user feels that each one of these kinds of data have on, say, the overall result of the analysis. Now, when it comes to weather and climate analysis, there are scientists who have for many years been working with GIS as a tool when it comes to those forms of analysis. And by the way, you know what's really interesting is the way in which weather data has been presented to the public. Say, for instance, like maps like this, where now we're actually watching, say, in the Pacific, we're looking at the potentials, spawning of a typhoon, or in the Atlantic, looking at hurricanes, talking about El Nino and things like that. It's as if the world is kind of getting a lesson in weather, climate, meteorology. And how many times have any of you pulled up on your mobile device, say, a radar map showing weather patterns and things like that? It's just it's amazing how the general public gets information now that in the past it used to be the meteorologist, the scientist that dealt with that. And a story I'd like to share with you is as I'm making this video, it was in this summer that I live in the state that if you want to see tornadoes, this is the place to be, Kansas. Well, it was a Friday at Fort Hays, and Friday afternoon, and all of a sudden the tornado sirens went off. And what I did is I walked around my building. It was already Friday afternoon, so there weren't that many people, but I said, please, let's go down to the GIS lab. It's down on the first floor, and it's one of the more safer rooms in case a tornado did hit. So I brought everybody into the GIS lab, and I pulled up on our big screen weather data, so that way we were watching live the storm moving over the university, and we were checking out the cyclonic activity of the cloud systems, and we were getting speeds and velocities at different weather stations. And what it did is it turned into a really interesting day. We were actually analyzing the weather patterns, and so, by the way, nobody got hurt. No tornadoes formed. But I thought, gosh, here we are in a world now where the data is right there. And it was just it's just fascinating. And so when it comes to weather and climate analysis, whether it be the scientists or just the general community, GIS provides simple display of information, but also can assist in the modeling of weather patterns and climate. Now, when it comes to the 3D GIS environment, things just keep on getting better and better. And I guess when it comes to the gamers out there, that's the most wonderful thing that they can hear, that the three-dimensional environments that they use for gaming is going to get better, look better. And by the way, this image that you see here shows a little bit of processing. To the left, you see an input-output. The output's kind of generalizing the surface there. But there are a variety of ways that GIS can render three-dimensional world. And as I mentioned a few slides back, three-dimensional, everybody, it allows human beings to bring in our analysis that the computers can never really do, and that is a subjective analysis. When you look at something and you say, I see the following. Why? Because human beings are wonderful at analysis, but there are things we just can't teach computers when it comes to looking at a place and making decisions. And so 3D, it has its place. Now, here you see a three-dimensional rendering of Portland, Oregon, and this thematic map is showing zoning regulations, and you see these spheres that are representing some aspect of zoning. Now, they say a picture is worth 1,000 words. Now, can you imagine if you, say, at a city council meeting, you gave people a report with data in there and you said, well, when it comes to zoning, these areas are rather restrictive versus these other areas, and that's what's holding back economic development. People would kind of scratch their heads and look at the numbers, okay, and okay, then okay, and they would do their best to make a decision. But can you imagine when you give them a graphic like this? And you say, okay, now here, you see, here is how, say, this zoning regulation is being enforced all across the city. And then people have those aha moments like, oh, you're right, that's right next to that business district, or it's right next to that area that we're trying to see if we could help out economically. So we are human beings, we're visual creatures. We love seeing pictures. Maps, visually, everybody, are the most efficient way of communicating more information versus any other method. Now here we see a GIS that has mapped out Mount Everest routes, and by the way, this is a way of representing the landscape where we use something called draping, where we take a satellite or air photo image and we kind of drop it on top of what we call an elevation model, which we'll get into in another lecture. And right now this is looking straight down. However, though, if the view was tilted a little bit, so you had looked at the oblique, it would look considerably like you were looking at a picture of Mount Everest, say maybe taken from an aircraft. Now, when it comes to community safety and hazards management, everybody knows what happened during 9/11. Now, it was towards the southern half of Manhattan Island that the World Trade Center Towers 1 and 2 existed. Now, in this image, using satellite imagery, it unfortunately depicts the aftermath of the 9/11 attacks on the World Trade Center Towers, and what an awful day that was for those of you who remember that horrible day. Well, picture this now, everybody. The area is in shambles. Many people dead. Well, you know the history behind it. GIS played an integral role in managing that area afterwards because it was utter chaos. But utilizing GIS when it came to doing things like, say, for instance, shutting down gas lines and things like that, so that way fires wouldn't break out throughout New York City, management of resources and things like that, all these aspects of disaster response management being made more effective thanks to the use of GIS. Now, when it comes to the management and containment of diseases throughout the world, there are various organizations that are robust users of GIS. Now, this map is a cartographic product that's representing the total deaths attributed to Ebola. But when you look at a dynamic GIS trying to manage the landscape, the question is, okay, if people are infected in one area, how would that spread to another area? How could you contain a disease? And so in a way with the GIS, what you do is you try to be one step ahead of the spread of a disease, but also back to management again. You have a certain amount of resources, you have to get people from point A to point B, and you have just all these aspects of trying to handle this terrible situation. And so once again, GIS is a proven effective tool in a scenario like that. But also even in, say, for instance, the United States, the Center for Disease Control, GIS is used in order to contain and well, plan in case of outbreaks of various kinds of diseases throughout the U.S. Now, when it comes to GIS in agriculture, let me tell you another Kansas story. When I first came to the Kansas, and this was back in the early 1990s, there was a sign that they had by the highway saying, "One Kansas farmer feeds so many people and you." And that was a way for them to say, hey, by the way, we have very productive farmers, very productive fields, you name it. Well, now when I drive by that sign, that value has increased significantly. Now, the state of Kansas didn't suddenly grow bigger. What happened is farmers became more efficient in the way that they grow things. And here, by the way, you see one of the telltale farming practices, field practices, a pivot irrigation pattern that you see within the area that I live in. Now in combines, those vehicles that you see driving around the fields that are harvesting wheat or whatever, they have GPS within them. And what that allows it to do is it allows it to identify location on the fields. So things like, say, for instance, when you identify an area that needs more fertilizer, okay, then maybe you'll fire some more pesticides on those areas. Or there's a variety of things that farmers know about the fields that when they can identify location better, all of a sudden the yields of those fields increase. And so that is one of the reasons why agriculture has, well, particularly in the state of Kansas, has become more effective. However, there are other reasons too. I don't want to make it sound like it was just because GIS, all of a sudden we have a whole bunch of food, but it did play a major role. Now, GIS can be dished out in a variety of ways, and there are different types of data sets. There are different types of configurations, some that allow users to edit with other users, some that are geared more towards internet use, and there are different types of GIS data models. There is a lot of complexity that is out there, but really the question is this: what do you want to do? And once you know what you want to do, the information is there on how to set up your GIS and what is the best hardware and software. But still, I guess the point I'm trying to make is that really it isn't one size fits all. There's a lot of flexibility when it comes to the kind of GIS that you create. Now, how far can you go with GIS data? Well, you can go off planet too. Welcome to Mars, everybody. And NASA has done a wonderful job of gathering information about Mars, but also other celestial bodies. And that data is available for the general public. And matter of fact, in one of my other classes, we decided we wanted to terraform Mars. We took the NASA data and we flooded Mars, and we did a little bit of it, a little bit of this and a little bit of that. And before you know it, we had a totally different landscape, and also identifying landing sites and things like that. So there's some pretty fun exercises that we've attributed to this data. But it kind of brings up the point that there are other planets around us, and we are exploring them. And GIS is a wonderful way to store the data, to analyze the data, and to share the data with the world. Now, related to space is this interesting application that's dished out through the internet called JTrack, where it allows you to see all sorts of things that are floating in at low orbit around the Earth. For instance, when they used to have the shuttle program, I used to watch when the shuttle would go up and dock with the International Space Station. International Space Station, at least from when I'm making this video, it's still up there. And also, JTrack has another function where you actually could see high orbit and see all the junk. Well, satellites too, okay, the good stuff, things that are still working, but just all the things that are floating around the Earth. I could see why NASA is worried about stuff accidentally hitting the International Space Station, because once you check out JTrack, you realize just how much is out there. Well, to conclude, everybody, the future of GIS. Computers are getting more powerful, software systems getting more efficient, more geographic data being shared on a daily basis. What that's doing is it's creating an integration of information that has never been seen before in human history, and that's a good thing. The reason being is that now it is becoming an instrument of amazing effectiveness to help us live our lives, solve problems, but also, everybody, with all the problems that the Earth has, it's a system that is providing the means for us to manage resources that are slowly being depleted, or not slowly in some cases, but still, I guess the point I'm trying to make, we're becoming better planetary managers because we have ability to see all the information and let the systems analyze and help us make better decisions when it comes to our daily lives and managing this planet. But the bottom line is this: when it comes to GIS, we need competent personnel in order to make this all happen. And my hope is, again, that once you're done with this class, you will have the adequate theoretical and technical background to be a competent GIS user and utilize this software in a manner that you see fit. Thank you.